Good morning, dear student. In today's lecture, we are very much interested in the polysaccharides. So, what is this polysaccharides? Polysaccharides are found in nature, and there are two types of these polysaccharides. One is storage polysaccharides, and second that is structural polysaccharides. Okay, these are the high polymers of monosaccharides such as glucose, galactose, fructose, and maltose. So these polysaccharides, they are found in nature, and there are mainly two types. One is storage polysaccharides, another is structural polysaccharides. Okay, and they are the polymers of monosaccharides. So monosaccharide act as a monomer, while this polysaccharide act as a polymer. Okay, so number of monosaccharides are joined together to use the polymeric network. It is called polysaccharides, and the monosaccharides such as glucose, galactose, fructose, and maltose act as a monomer in this polymer formation of polysaccharides. Okay, so let us discuss the classification of these polysaccharides. These polysaccharides, if you see this, okay, these polysaccharides are classified into two types. These polysaccharides are classified into two types. One is homo polysaccharides and second is heteropolysaccharides. Okay, so what is this homo polysaccharides? Those polysaccharides which is on hydrolysis gives only a single type of monosaccharide molecules. They are considered as the homopolysaccharides. So the polysaccharides are classified into two types. One is homo and second is hetero. So what is this homo polysaccharides? These polysaccharides which is on hydrolysis gives a single type of monosaccharides. Therefore it is considered as homopolysaccharides. While what is this heteropolysaccharides? These are the polysaccharides which is on hydrolysis gives the mixture of constituent of monosaccharides and some derived products. Okay, therefore they are considered as a heteropolysaccharides. So in homopolysaccharides we get only one kind of monosaccharide molecule upon hydrolysis, while in heteropolysaccharides which is on hydrolysis gives the mixture of constituent, and therefore they are considered as a heteropolysaccharides. Again, if you see this, these homopolysaccharides are mainly classified into two types, that is storage and structural polysaccharides. Storage and structural polysaccharides. The storage homopolysaccharides again classified into two types. One is the plant origin and the second one is the animal origin. The plant origin polysaccharides are, we are very much familiar with this, that is starch, and the second, that is animal origin, is your glycogen. So they are act as a storage homopolysaccharides. And the second one, that is structural homopolysaccharides, again they having plant origin and the animal origin. The plant origin, the best example is your cellulose, okay, which is obtained from the plants. And the second one is the animal origin, that is your cythin. Okay, so this is the classification of these polysaccharides. Polysaccharides are nothing but the polymeric compound of different monosaccharides. So monosaccharide act as a monomer, while these polysaccharides are the polymeric network, and the monosaccharides are glucose, galactose, fructose, and maltose. Okay, some monosaccharide is there, some disaccharide is also used. Again, they classified into two types. One is homo and hetero. Homopolysaccharides which is on hydrolysis gives same kind of molecule, same kind of monosaccharides, therefore they are considered as a homopolysaccharides. While heteropolysaccharides which is on hydrolysis gives different types of gives mixture of constituent. Okay, and therefore they are considered as heteropolysaccharides. And the homo, again it is converted into two types, that is storage and structural. The storage which having plant origin, the example is starch, while the animal origin is your glycogen. And the structural which having the plant origin, example is cellulose, and the second, that is animal origin, that is your cythin, that is your cythin. So let us discuss the first one, that is storage polysaccharides. Storage polysaccharides, that is your starch. Okay, so we are very much interested in the storage polysaccharides which is obtained from plant, that is your starch. Okay, so let us discuss the first one, that is your starch. Starch, okay, it is found in all plants. So this starch, it is found in all plants. It is found in all plants. Okay, and if you consider, uh, it is formed by the alpha glycosidic linkage. It is found in all plants. This is the first point. The second point is very important, that is it is formed by alpha glycosidic linkage. Okay, so we are very much familiar with this alpha glycosidic linkage. Okay, 1,4 linkage is there. Okay, and if you consider, it is a mixture of two substances. This starch, it is a mixture, of two substances. It is a mixture of two substances. Mainly, it is a mixture of two substances. That is first, that is amylose, and second, that is amylopectin. Okay, so this starch, it is found in all plants. It is formed by alpha glycosidic linkage. It is a mixture of two substances. One is amylose and amylopectin. So what is this amylose and amylopectins? So let us discuss it. What is this amylose and amylopectin? So to see some distinguishing point regarding to this amylose and amylopectin. So the common difference, so this is your amylose, and here this is your amylopectin. So if we see the first point, is common in both these amylose and amylopectin, that is both are made of glucopyranols. So we are very much familiar with this glucopyranose and pyranose structure. Pyranose means 6 membered and pyranose means 5 membered. So both are made up by glucopyranose. Or we can write here, they are made of glucopyranose. They are also made of or from glucopyranose. Means the monosaccharide is your glucose, and it is a 6-membered cyclic structure in hemiacetal form. And they forms the amylose and amylopectin. So the basic unit is same in both the cases, that is your glucopyranose. Okay, and the glucose units are joined by alpha 1,4 linkage. Okay, so in this case, we see this amylose, the glucose, it is joined by alpha 1,4 linkage. Glucose molecules, number of monomers are joined together by alpha 1,4 linkage to form unbranched structure, to form unbranched polymeric structure, unbranched polymeric structure, polymeric structure, unbranched polymeric structure called amylose. So if you see this, the glucose, it is your monomers, they are joined by alpha 1,4 linkage and to form unbranched, that is linear sequence of these monosaccharides, linear sequence of this glucose molecule to form the polysaccharides such as amylose. Okay. But if you consider this amylopectin, it is a branch polysaccharides. This is your branch polysaccharides. So this is your branch polysaccharides. This is your branch polysaccharides. Okay, this is your branch polysaccharides. Okay, so this is the linear sequence and this is your branch sequence. And the next point, if you see the molecular weight of this amylose, then it is up to 60,000. The molecular weight it is up to 60,000. The molecular weight, which is equal to 60,000. And if you see the molecular weight of this amylopectin, it is up to 5 lakhs. Molecular weight, it is up to 5 lakhs. Okay, so this is the difference. Okay, so this is a branch structure, branch polysaccharide. This is a linear polysaccharide. Its molecular weight is 60,000 and its molecular weight is up to 5,000. Its molecular weight is up to 5 lakhs. Okay, and if you see this amylose, it is in the unbranched chain. If you see the linear sequence of these monosaccharides, the unbranched chain which is formed, it is in the alpha helix form. Okay, alpha helix form. So let us discuss the next point, that is the linear change in the alpha helix form. So this is very important. The linear chain, it is in alpha helix form. So we are very much familiar with this alpha helix. We already discussed in the proteins and amino acid. So linear change, it is in alpha helix form. Okay, and if you consider there are total 6 glucose molecule in each turn. 6 glucose molecule in each turn. Okay, in each turn. So if you see, this is your structure. Okay, this is your alpha helix structure and this is your one turn. Okay, so this is your one turn. From this to this is your one turn, and there is a total 6 glucose molecule in each turn. There is a total 6 molecule in each turn. Okay, so this is the difference. One is linear sequence, another is branch polysaccharides. Its molecular weight is up to 60,000. Its molecular weight is up to 5 lakhs. And if you see the difference, that is, it is a linear, it is a branch. Then the next difference is that or the same properties, that the monosaccharides is your glucose, that is your monomeric unit. They are joined by alpha 1,4 linkage, alpha 1,4 linkage. Okay, the main difference is only the branch. One is unbranched while the other is branch, and the another difference is the different molecules, that is, it is a alpha helix form, it is a branch form. Okay, and different molecules, that is each branch, if you consider this case, that is each branch is at an interval of 24 to 30 glucose unit. Each branch is at interval of 24 to 30 glucose unit. Okay, so after each 24 monosaccharide molecule, there should be a branch. That is, the branching is from 24 to 30 glucose units. So these are the some important points. In the next lecture, we will discuss the structure of this amylose and amylopectin and remaining polysaccharides. Thank you.